Hello everybody, thanks for checking out this video on Lewis structures. So again, for videos, what we're gonna do is if things are going too fast, just make sure that you stop the video. You can pause it to write some stuff down and to think about what's going on. Don't ever say that I go way too fast, because you can pause it and you can re-watch things and rewind. It's the beauty of video. All right, so we're gonna go over Lewis structures today. Lewis structures are just a drawing of a molecule that indicates what kind of bonds are between atoms, and then what kind of electrons, or where electrons are located as lone pairs on your atoms. So these are only drawn for molecules that have covalent bonds. So if you remember from last week, we did these with the ionic bonds when we transferred electrons between some atoms. We drew some arrows. So what we're doing today are just covalent bonded compounds, so compounds with covalent bonds, sharing electrons. So to draw these, take a minute. We need a paper P table with the valence electron numbers on them. Your P table, your online P table, electronegativity values, that just helps us figure out where the center atom is in our molecule. Some paper, you need some scratch paper or just some notebook paper, and then colored writing utensils. I like using different colors to show different things. Again, be organized, be clear, be clean. If you're really messy and you draw things all over the place, it's going to look like a mess. So what we're going to do is draw the Lewis structure of what is called formaldehyde, in other words, CH2O. So again, anytime this video, if you need to take a minute to think about some things, just pause it. No big deal, obviously. So formaldehyde is CH2O. So to draw Lewis structures, it's similar to last week, where we have to make every atom happy in the molecule. If I look back to my P table, every atom wants to be like a noble gas. It wants to have the same number of valence electrons as the closest noble gas here in group 18, or the noble gas group. So what we're going to do is try to show that by drawing a structure. So first what we need to do is arrange our atoms. So in this kind of molecule, we have a bunch of nonmetals, so they're not going to transfer electrons, they're going to actually share them, like we learned recently. So when arranging your atoms, the atom with the lowest electronegativity is going to go in the middle. Electronegativity values, if you remember from, again, a little while ago, the ability for an atom to steal electrons. So what I tend to use is my online P table, just to see what the rough values are. Now again, we learned that the biggest ones are towards the top right, like fluorine's the largest, and the smallest are the bottom left, like francium and cesium. So if we're checking our atoms out, the lowest electronegativity valued atom goes in the middle, except for hydrogen. Hydrogen can only bond one time, so it can't be in the middle of our molecule and bond multiple times. So we're going to check C and O, and you don't even need to know the numbers, it's just roughly where they are on the P table. Oxygen's closer to the top right, so it has a larger electronegativity value, so carbon is going to go in the middle. So how I'm going to do this is I'm just going to draw a carbon in the middle. I need two H's and one O. So I'm just going to go, I don't know, H, H, and O. So that's the arrangement of my atoms. Carbon is the lowest electronegativity, two hydrogens and one oxygen on the outside. So everything is going to bond to the center atom. So what we did last week is when we did valence electrons, I'm going to use blue for valence electrons, we used arrows. And we kind of made like a square around the atoms. So it's kind of like the atom has four spots for valence electrons, kind of like a square has four sides. We got this side, this side, this side, and this side. And what we want to do is put an arrow showing valence electrons around each one. So using your P table, I'm going to do half arrows. Hydrogen's got one valence electron, so I'm just going to show one, just like that. Carbon has four. So like we did recently, I'm just going to put one valence electron on each side of my atom. Oxygen has 6. So I'm going to do is put 6 around it. So I'm going to go 1, 2, 3, 4. And once you fill up 1 on each side, they have to pair up. So I'm just going to put 2 in now. I'm going to go 1 and I'm going to go 2 right there. Now if you're like, wait, how do why do I put the extra ones here and here? Once you get the hang of this, you'll know where they're supposed to go. It just makes your drawings a little easier. So what we're doing is we're trying to show how the electrons bond. So how the electrons get together and bond. So again, hydrogen doesn't like having the 1 there. Hydrogen doesn't like having 1 here. Carbon doesn't like having 1, 1, 1, 1. They want to be paired up. But they're not going to transfer because these are covalent bonds. They all want some of these electrons. So what we're going to do is try to show that they are bonding. So this electron is going to bond with that electron for carbon. And note that they create a nice little bond there. 2 electrons in a bond. Note here that these 2 are all alone. They're going to pair up. And now note here a very nice connection we have between those 2 electrons, 1 for carbon, 1 for oxygen, and the same thing here. So note that we have a bond there, a bond there, a bond there, and a bond there. And we still have these extra electrons here, but that's okay because those are already paired up, so they're not going to really do anything. All the other atoms are fine. So this looks like a mess. So Lewis structures actually are, they use dots. So what I want to do is transfer this, to make it look better. So this is a big old mess, okay? If I have to look at a bunch of structures with a bunch of circles and weird arrows, it just becomes a disaster. So how I want to transfer that is I'm going to draw it to make it look nicer. And these are real Lewis structures, but this over here, this is the work shown to make the Lewis structure, to kind of prove that electrons do what they do. So what I'd like to show is that we have this bond here between the C and the H. So I'm just going to draw a bond between the C and the H. Same thing over here, bond between the C and the H. And then down here, I've got actually 2 bonds between the C and the O. So I'm going to draw 2 bonds. But we're not done yet because we have these extra pairs of electrons on oxygen. So I'm going to draw those down here in pairs. Note that here they're in pairs. So we keep them in pairs, all right? Don't just go like 1, 2, 3, 4 all willy-nilly like that. You need to keep them together. All right, I'll get to that. And this is correct. And there we go. So that is what's called a Lewis structure of a molecule. So just to do another fast one, again, if this was too fast, just slow it down, okay? Take your time, draw some of your arrows out. Everything should work out though. We're just trying to make the electrons match up and pair up with something else. There are some weird exceptions, but we'll get to those eventually. This is just kind of practice time. The last one I want to do is water. So I want to show how water gets made. So we're looking at water, it's H2O. The lowest electronegativity atom goes in the middle, except for hydrogen. So it has to be oxygen. So I'm just going to draw O. And I'm going to put 2 H's on the side. So for my valence electrons, hydrogen is very nice, it only has 1. Oxygen, like we just showed for formaldehyde, oxygen has 6 valence. I'm just going to draw 6. So again, it has to go 1 on each side first. If you start pairing up immediately, you're going to screw up. It's just going to happen. All right, so you have to, there are rules to follow, okay? And then I start pairing up. Since I know what it's going to look like, I'm just going to do that. All right, so those are all my valence electrons, and if we try to see what's going to bond, here are 2 solos, and here are 2 solos, and they're going to bond, which is nice. But that looks like a mess, so to make my Lewis structure look nicer, I'm going to put O in the middle, 2 H's, Now again, I have a bond between O and H and a bond between O and H. I'm just going to show that. And then I have these two unshared pairs on oxygen, kind of just up here. As long as they're on oxygen, it's okay. It can go on the opposite sides and on the top. Again, these things are flying all over places when they matter. And that is your water molecule. So take some time, kind of go through some examples, give it a shot. We'll have to go through some more in the future. Great, thanks for watching.